So hi everyone, welcome back to the channel. It's been quite a long time since I came up with a video. I was very busy with a lot of things on my side, but anyways, it's been a long time, and I thought I'll put out a video. And today's topic is going to be my opinions on Web 3.0 and decentralized apps. So the format of this video is a little bit different from the usual style. In case you haven't noticed, I am recording this video using StreamYard. So it's supposed to be a live stream, but this is a recorded version. And if it turns out good, I'm going to upload it or maybe run it as a live stream, but it's still going to be a, pre-recorded video. And just want to experiment with this new style and format to see how it works. So this is an amazing platform. Anyways, just my opinion, and I'm just exploring this platform. So it allows people. Generally, if I record any video, if I do any work where I need to share my screen or my work on my laptop or computer, I use a very known and very popular software called OBS, Open Broadcaster Studio, which is a free and open source piece of software. It's like the industry standard, which you can again develop on top of for recording yourself, recording your screen for any kind of recording work. But this video, I'm using StreamYard, which is a fully online web-based platform, very simple to use, and it has a lot of features geared for streaming rather than just recording yourself. So it allows you to create these different styles and formats, these presets, which you can quickly switch between. You can add overlays, you can add custom branding. And what I really like about this tool is it makes it like really dead simple for you to involve different co-hosts, invite people on to your show if you're having some kind of show or podcast. So it makes it really simple. Like all I need to do is invite someone using their email or copy and send them a link. They get joined in. I can set custom permissions, and like we even have a private chat room. So it makes it really simple, and then I can quickly switch between these preset layouts or um, yeah, layouts. So let's get into the topic of the video. It's going to be a little casual and lengthier video than usual, not very focused and me jumping from point to point. So to understand this topic, I'm going to explain a little bit about what decentralization is in general first, in case anyone doesn't know. So today's world, a lot of things are centralized. If you take any kinds of financial transaction, it's all centralized. It happens through our banking system. It happens through banks. If I take my debit or credit card, if I want to purchase something online, let's say purchase something on Amazon, I use my debit or credit card, and it goes to the banks. The banks have to approve the transaction with various factors, such as they need to check my bank account if I actually have sufficient funds, and if everything's okay, they approve it. All the transfers are taken place. Now, of course, I'm not sending something physical. It's not actual banknotes or some kind of physical trade. It's all numbers on the screen at the end of the day. But this approval still takes place. The person who's doing the approval are these banks, and they're acting as these sort of middlemen. And these middlemen are present in all kinds of things. Even if you're talking about the internet as you use it today is fully centralized. So whether you're using some kind of mobile app or you're opening a website, let's say Google, for example, if you take Google, their website is hosted on a server. The reason you're able to go to google.com, which actually points you to an IP address, which is like a location, it points you to that server where Google server is located, and that's where their website is hosted. So it's centralized, right? It relies on these servers, relies on these companies. So for example, if I want to create my website, I have a few ways to go about it. I can buy my own computers, my own servers. So when I say servers, it's just computers at the end of the day, but it has dedicated purpose of just serving my website. That's all it's meant to do. It's not meant to play games or anything. So I could buy all the resources and maintain my own server, maintain my website, make sure it stays up all the time, and do all the work myself. And as more and more people use my website, it's going to grow in size, and I'll probably need to expand my resources, get a bigger computer or add multiple computers to that server to make sure it can handle the load. Now, that is a traditional way. That's what people were doing, and this was very expensive also, especially as an initial setup cost. Now, what people started to do was use the cloud. Now, the cloud, a lot of people misuse what it actually means. So, what it does mean is there are these companies which have all the resources, they have all the computers and have the servers, and they basically, in very simple terms, they rent out their resources. So you can use how much ever resources you want. Let's say you're just starting out, there's just like 5 people looking at your website. So you can ask them to allocate the smallest resources for your website and host it and deploy it. Now, let's say all of a sudden you have 1,000 users visiting your website every second, right? You can instantly tell them, no, I want to scale up, I want more resources, add 2 more virtual CPU cores or add more RAM, and they will do it instantly because they have the resources. They just need to allocate more for you, and this happens instantly. You don't need to go to the store and buy more resources, buy more computers, and manage everything yourself. They do the managing for you. Now, this is what the cloud is. And a lot of companies such as Amazon, Amazon's AWS, Amazon Web Services, Microsoft's Azure, and another smaller one is Google Cloud Platform or GCP. All of these players started becoming popular as they already had all of the computing power because they had a lot of services that people are using, huge population. And during periods of downtime or inactivity where less number of people are using it and they had less traffic, they noticed that they had an opportunity to like rent out these services so that other people can use them and make money. This is a second source of income. So this is how the centralized internet works. It relies on these servers, on these companies that own the server. Now, someone came along who came up with this revolutionary idea of decentralization. So, what if this entire system was decentralized? It didn't require any of this middleman. Now, it's not possible to make it in a way that it doesn't require anyone. You need someone, right? But instead of making it make the entire population dependent on one particular person, so if anything bad were to happen on that one particular system, the entire system fails instantly. What he thought of is let's make it distributed over a group of people. So this is all very vague and abstract. So let me get into it in a little bit more detail. So let's take Bitcoin for example, right? You guys understood the example that I said with currency transactions, financial transactions happens today. Let's say we're talking about these virtual currencies or cryptocurrencies. Let's say we're talking about Bitcoin. If I want to send some 5 Bitcoins to someone else, person A wants to send 5 Bitcoins to person B. Instead of this transaction being approved by a central authority like a bank, what happens is there is a group of computers, a network of computers all over the world. And what happens is it goes to this pool of computers, and all of these computers, which are called miners, they have to solve mathematically intensive task or a cryptographically intensive task. Now, this is something that is very powerful and requires a lot of resources. So, a simple computer like yours or mine is not going to work. You need specific resources like really high GPUs or specific hardware for crypto mining in order for all of this to work. So these people are all competing against each other. They're trying to solve this puzzle, and basically, the person who solves the puzzle first, they're the ones who are rewarded with Bitcoin in order for because they completed the task. And once they complete the task, and they're the ones who are rewarded with Bitcoin, transaction is approved and the Bitcoin is sent. So if you notice, a lot of times there's a delay. The reason the delay happens is none of this is instant. It happens over a huge number of computers, and for the change to reflect, it takes a lot of time. And the way it's designed is quite smart. Every transaction that happens is permanently recorded in this ledger across the internet. It's publicly available. Everyone can see every transaction that has ever taken place since the born of this cryptocurrency. So it's like blocks added on a chain. That's why it's called blockchain. Now it's very ingenious in the way it's made. That it's very I mean, it's completely based on math. It's made in a way that if someone tries to manipulate or alter one particular block in the blockchain, the entire thing doesn't make sense anymore. So this is a way to alert the systems or the rest of the network that this is inconsistent and something is wrong over here. So people, it's very hard for people to maliciously try to exploit the system. So that's how decentralization works, and that's how these cryptocurrencies work. So whether it's Bitcoin or Ethereum, this is just a surface level or very layman's term explanation of how the stuff works. So this process allows you to change a centralized system into a decentralized system. Now, if you take the internet, right, internet's also centralized. So this is what we call Web 2.0. This is what we currently use. Now, this buzzword Web 3.0 is what people are thinking is going to be the future of the web, where it's no longer centralized, but it is decentralized. Now, there are a lot of advantages, and I feel there are a lot of disadvantages also. I don't know if it's entirely practical and if it's going to work. But anyways, let me explain what exactly Web 3.0 is. So Web 3.0 is basically built on this blockchain technology so that the web becomes decentralized. So maybe I can give you an example. So as I said before, right now you need these servers, these corporations that own the servers in order for the web to take place. If you want to create a website, you need to host your website on one particular server. That's how it works. So Web 3.0, it's part of the blockchain. So the moment you release your code onto this network, it's permanently available forever. You can never change that. You can never remove it, even if you wanted to. So that's how Web 3.0 works. Imagine you create a website, and if you have a typo or you want to make some change or you want to pull it on the website, you can't change it. It's that forever. That's how Web 3.0 works. Now, this helps for certain people in a way, in such that um, there are some people who are being censored. A lot of countries censor information that they don't like. A lot of governments or countries in general, they have certain type of information that they don't want to be sent, and sometimes it's for good reasons. Sometimes it's because there's a spreading of fake news which they want to control. So a lot of times this is censored because they can track where the source of information is coming from. So if they see, okay, this particular site, this particular person is spreading a lot of information, they can just go and ban the IP address or ban that particular server from accessing the rest of the internet. So that's what happens today. And those people who are being censored dislike the current system, and they're the people who will really like this new system, which might come in the future, which is Web 3.0, as it's based on this blockchain technology, which is completely decentralized. So no one owns anything; it's distributed across a network of computers, and this prevents people from censoring or banning certain parts of information. So Web 3.0 and dApps or dApps, however you call it, or decentralized apps, they're pretty much the same thing. Instead of being centralized, instead of being hosted on one particular server, it's distributed across the entire thing. Now, I have a few issues with this in the first place. So, firstly, with cryptocurrencies in general, the way this works is quite ingenious, in terms of them having this cryptographic way of verifying these transactions. That all that makes very sense, and it seems really cool. But the issue is it takes a huge lot of computing power, right? Even for one transaction to happen, it's a lot of computing power. And there's actually this chart, so let me try to pull it out. So there's this chart of the power consumption from the Ethereum network. So many people, so many transactions are happening, right, on this network, and for every transaction that happens, you need to solve these cryptographic puzzles, and these are really computationally intensive. So when you're trying to solve these tasks, another important thing to realize is that you're also requiring electricity to use, right? That's something that you often ignore. So let's say you want to make money mining Bitcoin or mining Ethereum. You set up your mining rig with all your your custom build, and you have some dedicated GPUs to make the performance better and increase the probability of mining the tokens. But what happens is a lot of people tend to forget your electricity costs. So if you actually calculate how much you earned, how much you were rewarded, and how much electricity was consumed, a lot of times you end up at a loss because the amount of electricity you consumed was more. And this is a serious issue that people are talking about, is because this is going to become the future of how we interact with people over the internet, or what we use for all our financial transactions. Then this cannot be consuming so much power as it is today. So let me try to just share my screen and show you the stats. So these are some charts on the power consumption of Ethereum. So let's see. You have this one that says the estimated power consumption. This is in terms of gigawatts. So you can see the comparison between Bitcoin and Ethereum, for example. I'm just trying to see if it says. Yeah, this is the one I saw. So this is just for Ethereum. This is across the entire Ethereum network, and you can see how it's just going out of control year after year, and it's actually continuously increasing. It doesn't drop, and this is, I think, terawatt hours per year. So it's a lot of energy, and this contributes to this is what contributes to climate change. So the power that you're getting for this mining, it's at the end of the day coming from these companies that produce electricity from fossil fuels, coal mining, thermal power plants, and other sources. So the more energy you consume, the more it contributes to climate change, and that's going to be a big issue. Now, my second problem with this is it doesn't seem like it's going to scale very well. So, actually, before that, I have another thing that I want to share is the different types of apps that you actually have. Um, so this is just a comparison of some of the apps from Web 3.0 and Web 2.0. So a few of them are the wrong example. So for example, like this, I don't think Brave is a Web 3.0 app. I'm using Brave right now. Brave is a browser. It's just like Chrome. It's Chromium based, but I think that's a bad example. But what is a good example are, if you take storage, right? So let's example you're using Google Drive, this service over here. So you have Google server where you upload your photos and files to, and if something happens, Google's down for some reason, then you're not going to be able to access your files. It's just gone. So that's why people dislike centralization. But if you take protocols like IPFS, which is used a lot when you're talking about NFTs, right? So this is distributed, and this allows you to still upload and share files in a distributed manner over the this blockchain network. So there are a lot of alternatives, Web 2.0 and Web 3.0 apps. So you have WhatsApp and WeChat. WeChat is a Chinese app. You have an alternative which is this one called Status. There's probably a lot, and I have no idea what they are. I've not used a lot of them, so I'm not really sure. But you can see how the differences are. So you have alternative apps if you want to explore them. Now, the reason I'm sharing this is because my problem with this is I'm not really sure how it's going to scale. And let me try to actually pull up the Ethereum website, um, because on the Ethereum website itself, they actually have a part where they mention the disadvantages of creating decentralized apps on the Ethereum network, because I have an issue with how it's going to scale, right? Because on normal applications, right, like if you develop an app on the cloud, you can scale it instantly, right? And it's instant. People find it very intuitive. If you want to buy something or if you want to send a message, it's instant. But the moment you do this in a decentralized manner over the blockchain, or using dApps or dApps, right, it slows down instantly. You're right, people are going to experience sluggishness. I'm just trying to find. So yeah, let me find and share the screen. It's not going to, so the entire point is it's not going to seem the same, right? There's going to be a huge difference. It's not going to seem natural and intuitive to people at first glance. So what you're seeing right now is the Ethereum website. Just give me a minute. Yeah. So coming back to this point, so over on the Ethereum website, you can actually see they've given the benefits and drawbacks of these dApps deployment and development. So downtime is what I showed you. Privacy is an important thing as long as it's developed properly by the developer. And censorship, obviously, you can't censor; it's impossible. And those are where you know the, the benefits end. When you come to drawbacks, um, it's harder to maintain because if you want to push updates, it becomes a little bit more complicated. And performance is the main issue. Your app is not going to be as performant as if it was traditionally Web 2.0 if you're going to deploy it on the cloud or something. Network condition is another issue. It's just going to take time. Every transaction is going to take much time, and it's going to give you a bad user experience in general. So these are some of the issues that I feel exist with this, and I just don't see how it's a viable solution right now. Maybe it might work in the future. I think especially with things like NFTs, where you just want to trade and collect tokens, like it's essentially digital collectibles. You collect stamps or vintage coins or any kind of cards, trading cards, whatever you're collecting for long periods of time, and you're assuming that this has tremendous value in the future, or it's just a hobby, right? Before it was physically done. Now it's virtually done in the form of NFTs. So I think for those purposes it might make sense, but for transaction use, in your daily life, or for the internet itself to be replaced, I have a lot of issues with this, and I don't see how it's viable right now. So that concludes this video. This was a little long video. I really appreciate everyone who's joined me throughout until now. Especially now, I've crossed 100 subscribers after some time, and it means a lot for everyone who subscribed and is continuing to watch me. So, as always, please leave your feedback on comments. I'm always looking for ways to improve. And if you want a co-host, please let me down in the comments, or my email and my social media contacts are available in the channel description. You can reach out to me. And if you want to see any other topics, or if you want to talk about any other topics, please mention all of that in the comments too. I'll be sure to reply, and that'll probably be the next topic of the next video. So thank you for watching.